here we're going to take a look at an example of graphing quadratics in standard form. So standard form is when a quadratic is in the form ax squared plus bx plus c, where a, b, and c are the coefficients. Okay, they're just numbers in front of the x's. Now to find the vertex in standard form, we have to do a little bit of arithmetic. We have to take the opposite of whatever the b is and divide it by 2 times whatever the a is. So the x-coordinate will be the opposite of b all over 2a. Then to find the y-coordinate, we plug the opposite of b over 2a back into the function and then solve to find the y value. One thing to note off to the side here is that this plus c will tell us where the y-intercept is, because the y-intercept occurs where x is 0. And if you notice, if I plug zeros in for the x's, both of these terms will go away. They'll both be 0, leaving me with just c. So c will be our y-intercept. And then lastly, our a will tell us what the stretch and compress is to the graph. So, for example, if we look at example down here below, I have 3x squared minus 6x plus 1 equals my function f of x. So to start, I first want to find my vertex. And once again, to find my vertex, I want to take the opposite of b. Well, in that case, I have negative 6, so it's going to be positive 6. And then I want to divide that by 2 times my a, which is 2 times 3. And if I go ahead and do that, I'm going to take 6 over, well, 2 times 3 is just 6. So I'll be left with 6 divided by 6, which is just 1. Once again, that gives me the x-coordinate of my vertex. And then to find the y-coordinate, I have to plug the x-coordinate I just found back into my function. So if I take 3 times 1 squared minus 6 times 1 and then add 1 to that, I can solve this to find my y-coordinate. Well, 1 squared is just 1. 3 times that 1 is just 3. Negative 6 times 1 is just a negative 6. And then I have the plus 1 on the end. If I take 3 minus 6, I get negative 3. And then negative 3 plus 1 is a negative 2. So notice my vertex will occur at 1, negative 2. So on my graph, I can go positive 1, down 2, and I know that's going to be where the vertex is at. Okay? Once I plot the vertex, I always use my a to find my next 2 points. Right now my a equals 3. I can put that over 1 to find the next 2 points. It's going to go rise of 3 and run of 1. So if I go over 1, I can go up 3, and then over 1, up 3. Now, if you look, we cross the y-intercept, or the y-axis, at 0, 1. And if you look at the c on our function, it's at positive 1. So as we can see, we hit the y-intercept at 1. Now, to find my last 2 points, I'm going to need to plug in a value, an x value, that I haven't used yet. So if I look, I've used 0, I've used 1, I've used 2, but I haven't used 3. So I can plug 3 into my function to find my last, or my 4th point, and then use that to find my last point. So for instance, if I plug that in, I'm going to get 3 times 3 squared minus 6 times 3 plus 1. Well, 3 squared is just 9. 3 times 9 is going to give me 27. And then if I take negative 6 times 3, that's negative 18. And then I add 1 to that. Well, 27 minus 18 plus 1 is really equal to 10. So when I plug in that 3, I should be up at 10, which is going to probably be a little bit off my graph. And then likewise, if I mirror that to the other side, it should also be up 10. So my graph isn't quite to scale, but ideally you just just plug in an x value you haven't used, and then you can mirror it across the axis of symmetry to find that fifth and final point. So the graph of 3x squared minus 6x plus 1 should look like this.